Hello everyone, today we're going to be talking about vectors and how GPS uses vectors. My name is Ton and I'm joined with Jose. So, what are vectors? Well, a vector is characterized by two quantities and is usually represented by a directed line segment. The difference between a coordinate point and a vector is that a coordinate is a position, but a vector is a change from one position to another. So here are three coordinate points, A, B, and C. U is an example of a vector. The vector starts from the origin and goes to point A. U is -2, 2, similar to point A. Although the values look the same, they represent different things. Here is vector v, which is also -2, 2. Even though the vectors are in different positions on the graph, the vectors are the same because the position of the vector doesn't matter. The only important thing is what change it takes to move from one point to another. There are two main operations you can do with vectors: adding and multiplying. Adding a vector requires two vectors to be part of the operation. U is 3, 2, and v is -1, -2. By adding u and v, you get the sum and a new vector. In order to add the two vectors together, you add the x component and the y component of the vector. So the sum of u and v is 2, 0. Next is multiplying a vector. You only need one vector for multiplying. U is 1, -2. If you multiply 2 to u, you get a longer vector. To multiply the vector, you just multiply the x and y component by 2. The product of 2u is 2, -4.
Alright, to understand how GPS work, it's basically a signal that is sent out by a device, for example a cell phone, that is received by satellites. Now there's about 24 to 30 satellites orbiting the world right now. Now to fully understand how you are located, we mainly use a longitude and latitude coordinate system, which horizontal lines are latitude and vertical are longitude. For the satellites to be able to pinpoint your location precisely, we use the triangulation method, in which your device's signal is picked up by three satellites, in which their intersection point is where you are located, as shown in the first picture. And on the second picture, you can see the longitude and latitude lines. Now, to understand how vectors are used for GPS, I'll use this example. Let's say you are the blue dot, and you want to get to your destination, which is represented by the pink triangle. So how would you get to your destination? So you might find that you'll use your phone, you go to Google Maps, let's say. And Google Maps might give you different routes to your location. Now, depending on, let's say, traffic and how far of a distance it is and how fast or your velocity will be, the GPS will create these vectors lines and add them up to calculate the total time, the total distance. And depending if there's any traffic, there's any accidents, it will reroute and give you a new route so you can reach your destination quicker. Now, let's talk about vector spaces in Google Maps. Let's imagine the whole world as a vector space, and we're going to label it vector space A, in which the whole world will be a whole map of the world. And let's say I'm looking for a Taco Bell that is around UTD. It wouldn't make sense to use the vector space A or the whole world map because I'm looking for a specific area. So I'll zoom into just the United States map. It's looking, you can see it clearly, but it's not good. It's too broad. So I'll zoom in one more time. And I can call this subspace TX for just a Texas map. And it's looking better, but not quite enough. So I'll zoom in one more time. And I can call this subspace C, which is for city and counties, let's say. And here on the images, I got here a picture of, let's say, subspace TX. And you can see my destination is kind of there, but you can't see it clearly. If I zoom in one more time, I got subspace C, which clearly you can see the route I need to take to get to my Taco Bell. And that's how Google Maps use vector space. And thank you.